Hello. Okay, just to review what we did the last time, run over what's going on in volcanoes, and we talked about fissures and how the top of a volcano does not have to be the only place the lava comes out of, right? So there's a lot of pressure and lava is being forced up, and sometimes it comes out in different places. It could come out further than just the top of the volcano in other places, and where it escapes in other places, we call those fissures. And I gave you some things to look at with Lalani Estates and the fissure that opened up there in 2018. We also talked about tephra and how tephra is a mixture of ash, solidified lava, like once it goes out into it explodes up into the air and it solidifies, and hot cinders. Then we talked about pyroclastic flows and how a pyroclastic flow is an extremely hot flow of ash and cinder that's coming down. It's not lava, but it may as well be. You do not want to get caught in that. If you see it coming towards you, it's probably too late. It goes that fast. So, tephra and pyroclastic flow. Then we talked about volcanic island chains that can form because of converging plates. So you've got this plate here that's sinking below this plate, and it's forcing magma up, and you see these island chains here. These basically what they are volcanoes that have been forced up, and they become what we call islands. If the volcanoes are inactive or not hurting certain parts, areas, people will start to build houses and live on them. And then we came to hotspots. Hotspots are very important. That is how the Hawaiian Islands formed. A hotspot is not the same as the regular volcanoes that we think of. It's not formed in the same way. So I just want to review that one more time. And I have a video, it's like 3 minutes, that I want you to watch here. I have it queued up for you here, so let me show you.
Or simply hotspots. One explanation of such activity is the presence of a mantle plume, a regionally restricted column of hot rock rising inside the asthenosphere. When it reaches the base of the lithosphere, the rock partially melts, sending intrusions of magma upwards into the plate. Some of this magma erupts to form active underwater volcanoes, or, if activity is sustained, an active volcanic island. An entire chain of such islands forms because the plate carrying the volcanoes moves across the stationary hotspot inside the asthenosphere. This movement slowly carries the active volcano off the mantle plume, causing it to go extinct. A new island grows in its place over the plume.
So this is how it's different. The volcanoes only form if they're over the hotspot. Once they move away from the hotspot, it's no longer an active volcano because there's no source. There's no magma feeding it. And you can see how the new islands form as they move over, as the plate moves over the hotspot. The hotspot doesn't move, the plate moves.
When the plate motion changes, so does the direction of the volcanic island chain.
Even if the plate changes
The
direction,
inactive older islands cool and subside with distance to the heat source and experience significant erosion. With time, former hotspot islands turn into smaller, shallow islands and ultimately become underwater seamounts.
so we're saying even when the plates change direction, the same thing is happening. And then out here, we have the oldest one. Weathering and erosion will wear it down over time. And that will eventually happen to all of them, but it takes thousands, millions of years. And that's how hot spots form volcanoes, and that's how they form islands. All right. So next, I want to talk about volcanic activity around the world. So let's just look at this map for a moment. The red and green dots represent volcanic activity around the world. So I look here, I see a lot of activity. I look here, I see like a trail. It's very specific where these red dots are. And then I come over here and I just see red dot after green dot after red dot after red dot after red dot all over the place. Look at this. Here, here, here. Just like they're gathered here. And I look at this in relation to the oceans and the continents, right? So I see Africa here, South America, North America, Eurasia over here, Australia. Let's look at another view, just a simplified version. You can see this represents a volcanic activity. And then here, where this red line is, those are all those dots that we were seeing. Those dots that are in all those locations. Interesting, I don't see any down here by Antarctica. Another view, same thing, different view. South America, I see all these volcanic, all this volcanic activity happening on the west side of North America and South America, in the east side of Eurasia, and around Australia here. If I want to compare it with something, I would actually compare it to my Earth Science reference table. And now I can see what's going on. That dots that was going down that almost looked like a line, that right there, that's the Mid-Atlantic Ridge. Those are diverging plates, right? And we know when the plates diverge and they pull apart, magma comes up and new land is formed there, and there's a mountain range there. Those mountain ranges are formed from the lava, so that's what was going on there. But let's look over here where all the activity was happening. Look at this. All of this right here, look at this. These are all subduction zones. Every single one of them is a subduction zone. Even the activity we saw over here, the little bit of activity, subduction, 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 subduction. Where one plate is going underneath the other, it's forcing magma up. And it's forcing, the magma is pushing up the rock, and we have volcanic activity there. Here, 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 here. The Mariana Trench. We've got the Peru-Chile Trench. The Juan de Fuca Plate, it's sinking beneath the North American plate. The Aleutian Trench. But look down here where we saw nothing. Antarctica has nothing because there's no plate boundaries there. Interesting. Interesting. So just compare again where this was where all the activity was happening. And let's not get it twisted. Let's not forget that where those plates subduct, you're also going to have a lot of earthquakes. So earthquakes and volcanoes happening there. About 80% of the world's earthquakes happen right here. And most of the world's volcanic activity is here. And we call this area the Ring of Fire. That is the Ring of Fire right there. 80% of the world's earthquakes and many of the world volcanic activity, most of the volcanic activity is happening right there. It's called the Ring of Fire. I want to go back through, because I know a lot of you didn't have enough time to look at the slideshow and everything that was in it. Go back through, take your notes, and review. And again, there are some things on the science website. You can click the link in the slideshow and it will bring you to the website. Have a good day.